So this is going to be the lecture for volume and surface area for Survey of Mathematics. So what's going on? This is section 7.5. And we're looking at really just a lot of different formulas. Now for volume, when we're talking about volume, we're talking about space measured inside a 3D object. So, for example, if we talk about, like, say, a cube. Well, there's space inside this cube, and so we want to have some way of measuring it. Now, oddly enough, what we do is we tend to measure this space using smaller cubes. So one of the things that we're going to do is we might take a little cube like this. And we might ask the question, how many smaller cubes fill in this larger one? And the number of smaller cubes, we're going to use that as a measure of the volume. Now, sometimes we might have a, as they say, an even number of cubes. I want to be careful saying that. The number of cubes, it's all whole cubes. You don't like have half a cube in there, but sometimes you have fractions of a cube in there. But the number of cubes, whether it's whole cubes or parts of cubes that fill in this space, that's going to be that's going to give us our volume. And depending on the space that we're measuring, we're going to use different sized cubes. So for example, if we have a cube that's 1 inch by 1 inch by 1 inch. Well, the volume for a cube like this, the way we come up with the amount of space is we take the length times the width times the height. It's length times width times height, or 1 inch times 1 inch times 1 inch. And 1 times 1 times 1 is 1. Inch times inch is inches with a 3 on it. And we use the phrase cubed, inches cubed, when we talk about an inch with a 3 on it. So the volume of this little cube is 1 inch cubed. So if we're measuring a small space, we might use these cube inches or these cubic inches to measure that space. So we would fill that space with these little cubes, and the number of these cubes that fill that space, well, that's going to be the volume. If we're measuring a larger space, we might use cubic feet. Cube sort of goes off the board here, but it's going to be 1 foot by 1 foot and by 1 foot. Again, a length, a width, and a height. And this is sort of where 3D comes from. When you have 2D, you're measuring just sort of a length and a width. You have a flat shape that you could set on a table, say. So the bottom of this cube would be a 2D shape. And so we could lay it flat. So you have a length and a width. So you have 2 dimensions, or 2D. With 3 dimensions, we have a length, a width, and now we have a height. And so that's why we have 3D. Now again, the volume of this cube is going to be 1 times 1 times 1, or 1 foot cubed. Again, foot times foot times foot. We have 3 of these feet multiplied together. So if we have like a large room, say, we would ask, well, how many of these cubic feet fit into that room? And the number of cubic feet that would fit into that room, well, that's the volume of that room. So let's take a look at the volume formulas for some different shapes. So the first off is the rectangular solid. Now, what it's going to have is sort of a shorter distance. I'll call that width. I'll call this length. I'll call this height. So when we're dealing with cubes or rectangular solids, the idea of 3D sort of just pops right out. So again, we have a length, a width, and a height, and that's what the volume is going to be. So the volume is going to be length times width times height. Now, in these formulas, when you see these letters representing length, width, and height next to each other, that means we're multiplying these together. So this is length times width times height. So, for example, say I have a large box, and it has these dimensions: a length of 10, a width of 6, a height of 3. What would be the volume? Well, your length is 10 feet. Your width is 6 feet. Your height is 3 feet. So what we're going to do, the volume will be length times width times height or 10 feet times 6 feet times 3 feet. Now we multiply the numbers together. We're going to get 60 times 3, 180, and then feet times feet times feet is feet to the third power, or we say feet cubed. So what this is essentially saying is that if you take 180 cubic feet, this cubed has a length of a foot, a width of a foot, a height of a foot, you could put 180 of these into this box. Now, what you'll typically see in the text, they might write their answer this way: 180 cubic feet. And so that's going to be your answer. Now, a special case of this, and we've already looked at this, was the volume of the cube. And again, it's length times width times height. I put my length here, my width here. It doesn't really matter for length and width. You can switch those around. Now, the thing with the cube, though, as we saw with the cube earlier, where it's 1 inch by 1 inch by 1 inch, or 1 foot by 1 foot by 1 foot, these all have the same measure. And let's say it's some amount S. We're going to do the same thing here like we did with the square. Call that one measure S. So the volume, which is length times width times height, now becomes S times S times S, or the volume is just S cubed. So when working with problems that have a cube, you might only be given one measure of one of the sides, and then you have to use this formula to figure out the volume. So again, for example, let's say we have a cube and they tell us that this cube has a side measuring 10 centimeters. Well, in the volume, we'll have 10 centimeters cubed. So 10 centimeters cubed, now you can do this on a calculator. You can put 10 into your calculator, and there's a little exponent button that lets you use the cube or the 3. So you go 10 to the third power, or 10 to an exponent of 3. Or you can write it out just like length times width times height. So 10 times 10 times 10 is 1,000, and we have 1, 2, 3 centimeters. They're multiplied together, though, so we get 1,000 cubic centimeters. And again, in the text, they'll probably write it out as cubic centimeters. Now, if you remember your exponents, the other way you can do this, though, you can distribute that 3, not as a multiplication, but as an exponent. So you get 10 cubed in centimeters cubed, like that, and then 10 cubed is 1,000. And that's going to be your answer. So these objects, they sort of are easy to sort of fill them in with cubes would be fairly easy. They're sort of giant cubes of themselves, but rectangular shapes. But now we're going to get the spheres. In spheres, to fill in a sphere, you have to use fractions of a cube at some point. So our sphere something like this. Now the key measurement in a sphere is that radius r. And again, this is the center of the sphere. But we have this radius r going from the center to the side of the sphere. So the volume of the sphere is this. It's 4/3 pi r cubed. So we've got pi in here again. And again, you got to be careful with pi because with pi, we can be asked to come up with 2 types of answers, an exact answer and an approximate answer. So let's do an example with the sphere. And let's say this sphere has a radius of 10 millimeters. How do we find the volume of the sphere? Well, it's going to be 4/3 pi r cubed, or millimeters cubed. Excuse me. So we see that we could take the 3, 10 cubed is going to be 1,000. That's 4/3 pi. 10 times 10 times 10 is 1,000. It's going to go to 1,000 millimeters times millimeters times millimeters. It's millimeters cubed. And here we got to be a little careful. You see, the issue with an exact or an approximate answer, it's not going to just be with the pi. It's going to be at the 4/3. 4/3 is 1 1/3. And so if you express 4/3 or 1 1/3 as a decimal, it's 1.333333, and the 3's go on forever. The 3's just repeat. So if we round this, we're not going to have an exact answer anymore. Just like if we round this, we don't have an exact answer anymore. So for the exact answer, we got to sort of leave this in, we got to leave this in. So what do we do with 1,000? Well, we can at least combine these into one thing. You can think of pi and 1,000 as having denominators of 1. The reason is if you take a number and you divide by 1, nothing changes. You still get that same number. Excuse me. So we can treat these as 3 separate fractions multiplied together. Now, when you multiply fractions, you multiply the top numbers, or the numerators, together, and then you multiply the bottom numbers, or the denominators, together. So you're going to get this. So we can do 4 times 1,000, and with multiplication, you can switch the order of multiplication like you can with addition. The order doesn't matter. 3 times 5 is the same as 5 times 3. You just can't do that with subtraction and division. That doesn't work. Only with addition and multiplication. So what we'll get is 4,000 pi over 3 times 1 times 1, 3. So that's going to be your exact answer. Now, as an approximate answer, and we could round this, say, to the hundreds. And here, let me get my calculator real quick. We could do 4,000 times 3.14159. Use that bigger approximation, not just 3.14. So if we do that, though sometimes the book will actually have you use that smaller approximation, we'll have to identify that as it appears. So what we're going to get is approximately 4,188.79 millimeters cubed. And this is also millimeters cubed. Abbreviate approximate. So this would be your exact answer, or we want to preserve both a fraction and a pi. This would be your approximate answer. So another shape, actually a couple shapes where this is going to come up, is the cylinder. So the cylinder has the same radius on the bottom as it does on the top. So the volume of the cylinder, it's pi r squared, and that's the area of the bottom, or in the area of the top. And then we multiply that by h. So pi r squared h, this area times the height. And a pattern you sometimes see with these, you can see this with the cubes and the rectangular shapes. You see this with the cylinder as well. A volume is the area of a base times a height. The area times a height will give you a volume. That's going to give you a volume. I think there's like a swimming pool question in this section where you're trying to find the volume of a swimming pool. You can use this idea where you take an area, a part of the pool. Instead of a height, you're going to use a length. But if you have an area times any one-dimensional measurement, like a height or a length or a width, that's going to give you a volume. So with this one, again, because we've got pi, we want to be careful for exact and approximate answers. Let's do an example. So let's say we have something like this. And let's give it units. Let's call this, let's go feet again. So we have some really large tank is what we've got. We want to find the volume of this tank. We want to fill it with something. So there's a radius of 7 and a height of 21. So what's the volume? Well, again, we use our formula. Now, R we know is 7 feet. And the height is 21 feet. Now, squaring this means 7 times 7. And then we have feet times feet. And then we multiply by 21 feet. Now this is feet times feet. We got 2 feet. Feet times feet times feet. That's going to give us our third one. So we're going to get feet cubed out of this. We need to do 49 times 21. Now again, we're going to leave pi because we want to come up with an exact answer first. So 49 times 21 is 1,029 pi, and then 1, 2, 3 feet are multiplied together, not added, but multiplied. So that gives us 1,029 pi cubic feet. And that's the exact answer. Or for the approximate answer, we want to do 1,029 times pi. Let's approximate pi, 3.14159. So 1,029 times 3.14159. And so that's going to give us approximately 3,232 point, I'm going to round to the, well, we'll come out to the hundreds, but really it comes out to the tens. But we rounded to the hundreds feet cubed, or probably more appropriately for the text. And so that's going to be your answer. All right. So another one with pi. So another one with pi is the right circular cone. Now, for the sake of volume, what's going to come up with the cone, and this will come up with the period too, we have 2 types of height. We have the vertical height, which is represented by h. But then we have something called a slant height or an inclined height represented by L. And that's a measure along the side of the cone or the side of the pyramid. So we still have a radius. We have a vertical height. And then we have this thing, a slant height or an inclined height. And we represent that with L. Now for volume, we're going to work with vertical height. And the volume is 1/3 pi r squared h. It's the same formula as a cylinder, except now you got this 1/3 here. That's the same kind of formula. So let me do an example. So the thing you want to be careful of is make sure you use the vertical height for your volume. For surface area, we're going to be using, let me take a look here. We're going to be using that inclined height or that slant height instead for surface area. But for volume, we're going to use the vertical height. Let's say we're dealing with inches. We've got a radius of 10 inches and a height of 12 inches. What is the volume? So the volume, again, we're using vertical height. We're not using the slant height. We're going to use vertical for volume. So pi r squared h. Or pi 10 inches squared times the height of 12 inches, or pi times 100 inches squared times 12 inches, 100 times 12. We'll have 1,200 inches cubed. And then we kind of do this in a conventional sense, or we put the pi behind the number. Still means 1,200 times pi. So that's our exact answer. For the approximate answer, and again, I'm rounding to the hundreds. It does have to be something like this. 3,769.91 inches cubed. And so that's the volume of your right circular cylinder. So finally, we're going to get to the regular pyramid. And for this one, what we're going to have here, the base of this thing is going to be a square. So we're going to have S and S. We're going to have a vertical height H. And sometimes they'll draw the vertical height from the outside of the pyramid. But then we're going to have the slant height. Slant height, you take the middle of one of these sides and go draw a line vertically to the top of the pyramid, it's going to have a length of L. So there's a vertical height, and again, that inclined height or that slant height. And then you have the base, which is going to be a square. It's going to be the same. So the volume for this it's 1/3 s squared h. It's sort of similar, at least in concept, to the volume of a right circular cylinder. Again, you have an area, there's the area, that base there, times a height. That gives you a volume. So that'd be sort of what you would use if you're finding the volume of a rectangular solid, where you have the length, the width, and then a height. Then we only take 1/3 of it when we're dealing with a pyramid. Let me do an example of this. So let's say we have this regular pyramid where the base is 10 yards on each side and has a height of 7 yards. What's the volume? Well, the volume is 1/3 s squared h, or 1/3 10 yards squared times 7 yards. Or 1/3 times 100 yards squared. Again, you can distribute this exponent. 10 squared is 100. Yards squared is yards squared. Times 7 yards. Or 1/3 times 700 yards cubed. Now, for this one, again, we have to worry about exact and approximate answers. And the reason is 1/3. 1/3 is a repeating decimal if you try to represent that fraction as a decimal. So it's 0.3 repeating, and it repeats forever. So again, we could think of 700 as having that 1 underneath it. And 700 divided by 1 is still 700, and so that doesn't change anything. So we can multiply across. And so we're going to get 700 thirds yards cubed. And that's our exact answer. Or if we round to the nearest hundredth, and that's going to be it. So those are the formulas for volumes. This will be our approximate answer. Now, the other subject this section covers is surface area. And before we get to that, I want to do one sort of involved volume question. And it's one that I think does come up in the homework, or something like it. And it's going to be something like this. So let's say we have this rectangular solid, and let's say we bore a tunnel through it. Do something like this. We bore a tunnel through this thing. And the idea is that, let's say we have this is a half circle. Say this half circle has a width or a diameter of 2 centimeters. And then it has a length of 8 centimeters. And then we have 4 centimeters here and 4 centimeters up here. So we still have a length, a width, and a height. So the way we want to do this, to get the volume of this shape that has this tunnel bored through it, is we want to take the volume of the rectangular solid and subtract the volume of the tunnel. So we want to find the volume of the rectangular solid and subtract from it the volume of the tunnel. So what's the volume of the rectangular solid? I'm going to call this V. There's a little R there. That just means rectangular solid. So it's sort of another label I can put to volume. Well, again, it's length, width, height. So the length is 8 centimeters. The width is 4 centimeters. And the height is also 4 centimeters. So 8 times 4 times 4 is that. $128, I think. Yes, 128. So that's the volume of our rectangular solid. It's 128. So I'm going to put this off to the side. So now we need to find the volume of the tunnel. Now we're going to treat the tunnel as if this face and that face, these are half circles. So this is basically half a cylinder. So what we can do is we can treat this like it's a cylinder. And then we're only going to keep half of it. So the cylinder the face is 2 centimeters across. And the length is 8 centimeters. So the volume of this cylinder, C for cylinder, is pi r squared h. Now in this case, h is going to be this length. So the h will be the 8 centimeters. It's like we have a cylinder and we knocked it over. We knock it over, the height now becomes the length. Now, the diameter is 2 centimeters. So the radius, we take the diameter, we divide it by 2. So the radius, we just want half of this length, not the whole thing. So now we can come up with the volume for the cylinder. Or we'll get 1 times 8 is 8 pi centimeters cubed. Now that's the volume of the cylinder. Now our tunnel was half of a cylinder, not the whole thing. So we need to take half of this. So the volume of the tunnel is going to be 1/2 times 8 pi cubed, centimeters cubed. Or 4 pi centimeters. So that is the volume of our tunnel. So finally, we need to do the subtraction. So the volume of a rectangular solid minus the volume, T for tunnel, or 128 centimeters cubed minus 4 pi centimeters cubed. And this is really as far as we can go. Like what we might do is rewrite this as 128 minus 4 pi, and we can just put the centimeters cubed on the side. That's usually what the exact answer is going to be. This is the best we can do. Now for an approximate answer, and let's say we round in the hundreds, we'll do 128 minus 4 times, and again 3.14159, or 128. If we do this, just put this in the calculator. Approximate. .87 centimeters cubed. So this would be our exact answer. Gotta leave the minus there. This would be our approximate answer. So that's it for volumes. Next video we're going to do, we're going to look at surface area.